Hello, everybody, and welcome to a video lesson on diagnosing unusual attitudes. So this is a good video for IFR pilots when you can't see out your windshield, right? And you need to diagnose your unusual attitude. Private pilots will also practice this under foggles, and you need to use your instruments right here to determine what your attitude is and how you want to correct and recover from that. Now, the attitude indicator is a great tool to be able to do this. It should be the first thing you look at when you want to determine your unusual attitude or your attitude, especially when you can't see out your window. It's very cloudy. So a nose high attitude, in order to diagnose a nose high attitude, you first have to understand what an attitude indicator is telling you. Okay, so here in the orange, we have our artificial aircraft. And then the brown parts is the artificial ground. Okay, and then the blue is up here is the artificial sky. So this divider right here is the artificial horizon. So if you could see out your window, you would see the horizon sort of like this, and you're in this case, in this example, we have a nose high. So the nose of our aircraft would be something like this, pointed slightly above the horizon, right? But we can't see out there, so we have to use the attitude indicator. So the first thing you want to see is where the artificial aircraft is in relation to the sky and the ground and this artificial horizon. So if the dot of this aircraft, the center of this aircraft is in the blue, you know that the nose is pointed to the sky and you have a nose high attitude. For a nose low attitude, we have, again, now the center of this artificial aircraft is in the brown. It's below this artificial horizon. So if our artificial horizon, if we could see out the window like this, our aircraft nose, top of our nose would be something like this, below that horizon that we see out there. But we can't see it in this case, so we got to use the attitude indicator. And in this case, right, brown is the ground. You can kind of remember that. If your artificial aircraft is in the brown, then you're pointed to the ground. You have a nose low attitude. The attitude indicator can also tell you whether you're in a right bank or left bank, right? So again, the artificial aircraft so this casing of your attitude indicator and this part right here that's connected to the artificial aircraft, that is rigid, stuck to the rest of your aircraft. So this is like your wings, this is your nose, right? It's a really bad drawing, but if this is your aircraft, right, it's stuck to your aircraft. And the background, that's the artificial horizon, all this stuff, right, is connected to a gyro, so it stays set in space. So when you turn, that's what you get. You get this artificial aircraft to turn, but the gyro keeps the artificial horizon solid. So you get the same perspective as if we were looking out the windshield and we could see out the windshield. So here we have our right wing dipped into the ground and our left wing pointed up to the sky. We still have a nose low because the center is in the brown. Brown is the ground. So we have a nose low right bank in this case, so our aircraft would be sort of making a turn like that. In this case, we have a nose high left bank. So here first, you look at your artificial aircraft, the center of it is in the blue. It's above the artificial horizon, so we have a nose high. And then now we look at the wings. We got the left wing pointed towards the ground, the right wing pointed up, right? So this is like the aircraft is making a turn in this direction. That's a horrible arrow. I apologize. But so if we had the horizon something like this, right? Our aircraft then, if we had wings to this guy and a nose and a tail, that would be kind of our aircraft, right? We're nose high and we're turning to the left. Now, I also want to mention what you might also see on your other instruments because it's important to cross-check your instruments with one another to make sure you don't have, you're not just using one faulty instrument, which we'll get to here in a little bit. We have our instrument panel here. Let's first consider the nose high. So let's say our, horizon is here. Our nose is obviously up here above the horizon. So in a nose high, you're likely to see, right, your airspeed indicator will be decreasing because you're in a climb, and usually the airspeed indicator decreases. And then you'll also see here on the VSI, oops, why is that not doing it? There, here's the VSI. The VSI will probably show a climb, right? So it'll be a positive climb rate on the VSI. And then the altimeter, you're likely, depending on the power, but you're likely increasing your altitude as well. So make sure and cross-reference with each of these that they make sense. Now let's consider a nose low. So now let's say the horizon is up here, so our nose is low. So our attitude indicator would show our artificial aircraft in the brown. Usually our airspeed indicator in this case is actually going to be increasing. Our VSI is probably showing a descent, and our altimeter is probably also showing a descent. So again, make sure that each one of those jives with each other, because you don't want to just rely on one instrument because it could be faulty. So what do you do once you've diagnosed these different conditions? Well, to recover from a nose high attitude, you usually want to simultaneously add full power while leveling the wings. So here we already, in this case, the wings are already level, but if they were like this, we would want to level the wings and add full power when we have a nose high unusual attitude. And eventually we would lower the nose to the horizon with the yoke. But first, we want to make sure we get that power in when we have a nose high attitude, so we're not at risk of stalling out. For a nose low, to recover from a nose low, we want to bring power down. Sorry about that writing, but we want to bring power down to idle, then level the wings before recovering from our dive. So we want to make sure that we're not recovering from the dive with power up so that we don't overstress the aircraft, because this could be a really steep dive. And if we pull back on the yoke to try and recover from that dive with full power, or even not full power, even less than that, we could overstress the aircraft. So we want to put power to idle, then level our wings. In this case, the wings are level, but if they were not, we'd then level them after that and then recover from the dive. So we want to get that power out, get all that energy out before we make those corrections. And that's important so that we don't overstress the aircraft. So let's do an example of something you might see the FAA ask you, or maybe your flight instructor, where you're shown kind of a situation of a six pack and you need to figure out what the aircraft's doing and maybe figure out if any of these instruments are not working by looking at the other instruments. Okay, so let's go one by one. We'll start here and then we'll kind of move along like this and tell you, which each of these are doing based off these kind of arrows and the situation we see here. So here in the airspeed indicator, we have the airspeed right here at like 85 knots, and then we have this arrow showing us that it's going down. Okay, so the airspeed, the numbers, the values are going down. All right, now here let's move on to the attitude indicator. We have the nose of the artificial aircraft above the horizon here. So we have a pitch up, and then we also have a right wing towards the ground. So we have kind of a small right bank, nose up attitude there. Okay, now over here for the altimeter, we have this arrow showing, again, kind of an increase in the needles. So these arrows, and these are tricky because you want to make sure the arrows represent whatever moves on the instrument. So when we get to the heading indicator, I'll tell you it gets kind of tricky. But on the altimeter, the needles move. So the needles are going in this direction. So the needles are, the numbers go up in that direction as well. So the numbers are increasing. So our altimeter is also going up. All right, so now over here for our turn coordinator, this shows a right turn, just a little bit over standard rate, which is that notch there, and then slightly uncoordinated there. That kind of matches our attitude indicator with a right turn, right? All right, now here for the heading indicator. Now again, this arrow is pointing to the left, but that doesn't mean that this indication moves to the left. Again, the arrow tells on these figures that the FAA gives you, the arrow tells you what moves on the instrument is moving to the left. So on a heading indicator, this aircraft stays still, and behind it, this wheel of numbers spins to the left. So the numbers are actually going to get bigger. We're going to go from like 250, which we're at, to 260, 270, 28, 29, all the way up. So these numbers are going up. The vertical speed indicator, it's not going up or down. If it did have an arrow, it would be talking about this needle because that's what moves. But we have about a 700 foot per minute descent, which shows us in a climb. All right, so now we want to ask, like, do these all make sense? Well, the attitude indicator, again, shows nose high and a right turn. The turn coordinator matches that right turn. So nose high, we could be climbing, so we should maybe see airspeed decreasing. We have that. Okay, so that kind of matches, that matches, that matches. Our altimeter's going up, that kind of matches with the climb, right? We show a climb here, so that matches. And then a right turn, we would increase our heading from 250. That would increase. We'd move. So we're kind of pointed towards the west. That would take us to the north. That also jives with the heading indicator. So that's what's going on. We're in our right climbing turn in this situation. And we have no instrument. It doesn't seem that any of our instruments are faulty. So how do we diagnose any attitude, not just an unusual attitude, if we don't have an attitude indicator and it's cloudy, IFR flight, we can't see out our window? This can happen. We can lose attitude indicators for a variety of reasons. Maybe it's tumbling, maybe the vacuum system or something's wrong, right? So we kind of alluded to this before, but we can use other instruments. For nose high, remember we talked about that we're going to decrease our airspeed. So that arrow down means decrease. And again, nose high, our altimeter's likely going to go up, showing we're increasing in altitude with that nose high attitude. And then we're going to see that climb on the VSI. For nose low, it's kind of the opposite, right? Our airspeed indicator is going to decrease. That arrow increase. That arrow indicates that the values are going up on the airspeed indicator. Our altitude is going to decrease, and then we'll see that descent on our VSI. For a right bank, we're going to, any banks, right, we're going to use the heading indicator, maybe the magnetic compass, and our turn coordinator, assuming that those are still working. Now, if we had a complete vacuum system failure, then unless this is electric, we'll lose our turn coordinator and we'll lose our heading indicator. So our heading indicator in our right bank is going to, the number wheel is going to spin that right way, and our heading is going to increase. So here, if we're pointed north, right, we're going to turn towards the east in a right bank. So the numbers would increase, but the wheel would spin to the left. Hopefully that makes sense. Now, here in this magnetic compass, it's a little bit different value than our heading indicator. But let's say we're at 030 in this example. And this is a little bit different, right? Because turning to the right would actually take us to 060. So 06 would come under this center line here. And so it would kind of move, the wheel back there would move that way. And we'd get 03, 06 in a turn to the right. And then our turn coordinator would show, of course, the right wing dipping and a turn to the right. Now for a left bank, again, our turn coordinator is the thing we want to use the most. That shows a left bank here with our left wing, dipping down here where it says L. And then our heading indicator would go the opposite way. So we're pointing to the north. We'd fly towards the west if we were turning left, right? So that would actually, the number wheel would spin this way such that 330 and then 300, then 270 were up top. Now here on the compass, if we started at 030, like this compass shows here, again, a left turn would take us towards the north. 030 is like northeast. So it would kind of go this way, where the N would come under here. Then we would see, right, 3, 3, oops, 3, 3, and then like 3, 0, and we would continue through north to the west if we kept turning left. How do we recover from these attitudes without the attitude indicator? Well, to recover from a nose high, so let's kind of give our horizon there. So our nose is above the horizon. So to recover from a nose high attitude, it's the same thing, right? Same procedure. We're going to add power, we're going to pitch down and level the wings. But to level the wings, we're going to use the turn coordinator. To pitch down, we're just going to use our feel. So we're going to add power, pitch down by feel. Then we're going to level the wings with our turn coordinator here. Okay. And then how do we know once we're level? Well, you will know you have reached level flight when airspeed and altimeter, so our airspeed indicator here and our altimeter, have stopped moving. The needles have stopped moving and they start to reverse direction. And then our VSI reverses its trend and trends to 0. So those, you kind of have to watch the trends of those instruments to see, when your airspeed indicator and altimeter stop moving, and they start to reverse direction. That's kind of tells you, okay, that's level flight. Let's level off there. And then for a nose low, so let's make a nose low. So here's our horizon up here. Nose is below that. What we're going to do is we're going to decrease power. Again, same procedure, decrease power. So we're going to decrease power wherever the throttle is in this aircraft. Decrease power, then level wings, right? We decrease power first, then level wings, again with our turn coordinator, okay? And then we'll gently pitch up with feel. Again, we'll use that by feel, but again, we want to decrease power first so we're not overstressing the aircraft when we come out of that bank. Again, we will know when we'll reach level flight when airspeed and altimeter needles stop moving and start to reverse directions. And again, when our VSI reverses its trend and trends to 0 feet per minute. Okay, so let's do now an example where we might not have our attitude indicator. Okay, so in this example, I've blacked out or I've redded out the attitude indicator, and let's assume that it's tumbling wildly and you just know it can't be trusted. You can't use it. So how do we diagnose this unusual attitude? Well, we can still use the 5 instruments that we have. Now, again, remember these arrows point in the direction that whatever moves, whatever the thing is on the instrument that moves, that's where it's moving. So this arrow is pointing kind of, counterclockwise. So that's telling us that the airspeed is actually decreasing in value. Excuse me. Now, the altimeter over here on the right side, that's pointing clockwise and telling us that, again, the needles move on that. So the altimeter is actually increasing. Okay. Our turn coordinator down here on the bottom left shows us just a little bit over a standard turn to the right, a little bit uncoordinated. Our ball is not quite centered. So that's what our turn coordinator tells us, and that's important because that's the only kind of bank indication that we have other than our heading indicator here, which again, this arrow is pointing counterclockwise. And remember, on the heading indicator, it's the wheel of numbers that spins. So that means this wheel of numbers is going to spin this way. And so the numbers underneath the center point here for our aircraft is going to go from like 310 to 320 to 330. So we're turning from the northwest to the north. So we're actually in a right turn. So that, let's say this is, I'm going to draw an up arrow. That means our heading values are increasing. It's increasing from 310 up, right? Until it gets to north, and then it would go to 0, then 010, 020, it would increase again. All right, now our vertical speed indicator down here on the bottom right, that shows us in a climb, but it shows us that we're stable. It doesn't say it's trending anywhere, so it's in a climb. So let's see, do these all match, or do we have a wider system error other than just the attitude indicator? Well, we have the airspeed decreasing, our altitude is increasing, and we show a climb. So that kind of matches with a nose high attitude. So I think it's safe to say that our nose is high in this because those three things match. And then we have the turn coordinator showing us a right bank. And the heading indicator also shows that we're turning to the right because we're turning from the northwest to the north. So that also tells us we're in a right turn. So these two match as well. So all these seem to match. So we don't have any like system-wide errors like a vacuum system error or a pitot-static system error. We just have this tumble error from our attitude indicator, but the other instruments we can trust and we can diagnose that we're in a nose high bank to the right and we can correct accordingly. Before we finish up this video, I want to do one more example. And this time we have our attitude indicator. It seems to be working. Everything kind of seems to be working fine, but upon further judgment, let's analyze each one and see what we can determine about the attitude and if any, and if our instruments are making sense. All right, so the airspeed indicator shows we're very fast, right? We're almost near the never exceed speed, the end of the yellow arc, and it's increasing, right? This arrow is telling us the needle is going clockwise, so it's increasing. So our airspeed is dangerously high and increasing according to our airspeed indicator. Our attitude indicator, the nose is in the blue, so it's nose high and a right bank. Our altimeter, this arrow is pointed clockwise. So that means the needles are moving clockwise. That means our altitude is increasing. Okay. Down here on the bottom left, we have a right standard rate turn, a little bit uncoordinated again, but right turn. And then our right bank. Now our heading indicator, we have this arrow going to the left, so that means the wheel is spinning, wheel of numbers behind our aircraft is spinning to the left, so that means we'll go from 250 to 260 to 270. Okay, so that tells us we're turning from the west to the north. That's a right-hand turn. Okay, and then our VSI shows a climb. It's not trending anywhere, but that shows us a climb. So now, do these things match? All right, so first let's start with the attitude indicator and the turn coordinator. Those both match, so I'm going to give kind of green checks there. Now, also our attitude indicator shows a nose high. Also, sorry, one more thing. Also matches our heading indicator, right? We're turning from the west to the north on our heading indicator, so that matches with a right bank. Now, back to our attitude indicator, it's nose high. Again, it's in the blue. So that would indicate that we would be climbing. So that matches our altimeter, also matches our VSI. But it does not match our airspeed indicator, where nose high, right bank would be pretty hard to be already almost at our never exceed speed and still increasing airspeed. So what this tells us is that there's something wrong with the airspeed indicator. Now, that would lead you to think, what is different about the airspeed indicator than all of these other instruments? Well, if you think about it hard enough, you'll know that the airspeed indicator is the only one that uses pitot pressure from the pitot probe, right? That it also uses static pressure, but the altimeter also uses static pressure, and the VSI also uses static pressure, and those seem to be working fine. The airspeed indicator is the only one that uses pitot pressure, so this would lead me to believe that something is wrong with the pitot port, right, on your pitot probe. And if you're flying around in IFR with all this clouds and this moisture in the air, that would also lead me to believe that something is clogging that pitot probe, probably, most likely ice, and I would turn on my pitot heat right away and see if that corrects the airspeed indicator and makes it make more sense. Okay, so thank you guys for watching, and that has been our video on diagnosing attitudes.